everyone. Hope you enjoyed your lunch. It's my first time at Demuxed and actually also my first time on stage since my daughter was born last year, so I've got a few butterflies, frankly speaking, but more than anything, I'm really happy to be here with you today. I'm Kate, I'm from CDN 77, and today I want to talk about cache efficiency and how CDNs actually deal with the growing number of content to keep both cache hit ratio and performance at the best possible levels. So we'll probably all agree that CDNs are here to cache and deliver content, and that cache hit ratio is an important parameter in the delivery workflow. It's also clear that the volume of new content that's being created grows exponentially. We're now on a track to generate almost 150 zettabytes of data in 2024 alone, which is more than double the amount of data from 2021 and 10 times more than in 2015. And not surprisingly, a big chunk of it is video. So not only do we see a surge in content volume, but also the lifetime of content popularity changes dramatically. Especially in user-generated content, we see an abundance of new videos and new content that no one really cares about within minutes of its publishing. So we need to adjust our workflows to deal with that. So the content volume, its dynamics change, but what remains intact is the demand for cache hit ratio larger than, let's say, 98%. Mathematically speaking, the cache hit ratio depends on the relationship between cache size, level of CDN optimizations, and content composition. And when the denominator grows and we still want the same result, the other two in the numerator need to catch up as well. So we just throw more storage at it, right? Yes, we could, but that alone is not a sustainable solution. So to stay cost-effective, efficient, and sustainable, CDNs have been implementing smarter, more advanced caching optimizations. So I'm going to open this cache black box and give you insight into how the cache infrastructure works under the hood. I'll quickly touch upon how CDNs handle caching of standard file-based content, and that obviously includes HLS and MPEG-. And then we'll move to more complex optimizations that CDNs do specifically for video delivery of both live and VOD. So this is a simplified scheme of a multi-layer cache. In reality, there are even more layers than that, but I believe it does the job of explaining the setup. So a common implementation of CDN is a hierarchical network of servers where the overall cache efficiency depends, among other factors, on cache efficiency of a single unit. Therefore, first, we need to make sure that we effectively utilize the cache space of a single server. There are numerous cache admission and eviction algorithms that allow us to only cache content that is likely to be requested repeatedly. It's usually achieved by a combination of hard rules and rules based on probability. So once we optimize a cache space of a single server, we need to make sure that the cache scales across multiple servers and layers, and make sure that the content is not stored on more servers than necessary. And that's where URL-based consistent hashing kicks in. Another principle that makes the wheel spinning is a shared knowledge about what each server has in its cache. So in other words, we want to make sure that servers talk to each other and share the status of individual files. Sounds like a database, right? While possible in theory, it comes with many disadvantages in practice, which is why CDNs usually prefer Bloom filters over database in this scenario. So now we have a CDN where all servers in all layers utilize their cache space efficiently, cache unique content, and have access to information about what other servers have in cache. Now, when a server gets a request for a file that's not in its local cache, the server can fetch it anywhere within the entire CDN infrastructure instead from the origin, of course, as long as the file was cached at least once. Obviously, there are dozens and dozens of other optimizations, including consistent hashing in DNS or rewrite of resource URL in HTML on the edge level. or latency-based field pop selection between the first CDN layer and the origin. But I only have 10 minutes, and we're at Demuxed, so let's move to specific video optimizations. So when it gets really interesting is when we combine file-based approach with stream-based approach. Obviously, this is not a straightforward process, and we can only do it with permission from content owners to work with their content. In such cases, we can, for instance, pass manifests at the edge and thereby get much bigger visibility into the content. With that visibility, we can effectively shift from treating individual segments as discrete anonymous files to handling them as data streams with a known relationship between the files. And there's a nice paradox in it. Years ago, HLS and MPEG- allowed us to look at video as pieces of static content and made streaming easily cacheable and scalable. So now we sort of come back to the stream-like perspective and appreciate the visibility into how these segments work together. So for example, we can optimize routing by sending individual segments along the best path across all layers and thereby improve both performance and cache efficiency. Now, let's get back to admission and eviction algorithms for a bit. If you treat video segments as discrete files, the cache admission and eviction algorithms apply to them individually. So, as a result, we may end up wasting cache space on disjoint parts, meaning we would have to go back to the origin and fetch the missing pieces, which increases the latency and hurts the overall experience. But once we understand the sequence of the video segments, we can treat it as a continuous data streams. So instead of admitting and evicting only some segments, we can admit and evict continuous parts of the entire stream. Another optimization is transmaxing at the edge level. This is obviously a trade-off between CPU and cache hit ratio, but if we look at it purely from the cache optimization standpoint, sometimes it makes sense to transport a cache and cache a single format only, and then repackage the stream into different containers on the fly at the edge level. So, for example, we can transport and cache MP4 segments and convert them to transport stream segments at the edge. In theory, we can, of course, move the entire transcoding to the edge, but the trade-off between computing power and bandwidth costs often doesn't justify it. I could go on, but let me bring a couple more and then wrap up. So if we know the order of the segments, we can prefetch them before they get actually requested. It is used for both VOD and live, and especially for live scenarios, it brings performance benefits. The idea is that by the time a piece of video is requested by the end user, we have it already cached as close as possible to the end user. Furthermore, CDNs usually receive requests for n number of files at the same time. Again, if we understand the sequence of the video segments, we can make a decision in which order we start downloading them from the origin. And as a final optimization, I would like to mention something we've started playing with only recently, using a stream-based protocol for transfer across CDN layers. Especially for live streaming, we're now experimenting with replacing HLS and MPEG- on the backbone with stream-based pub sub-protocols such as SRT or media over quick transport. This approach drastically reduces the number of requests compared to traditional HTTP request-response methods, improves end-to-end latency, and effectively eliminates cache misses for the live stream. So, to an extent, CDNs are getting commoditized. At the same time, I'm still fascinated by how much innovation is going on under the hood, especially with the power at the edge and some insights into data we deliver. So, once again, thank you for your time. It's great to be here. That's all from me.